Here's number 6. You basically have a big Ferris wheel here, and you have a cart at the top with a passenger inside. And it wants you to find how fast you spin this so the people at the top feel weightless. Now, weightless is like kind of an interesting word. Basically, if you imagine you have a person who's falling out of a plane, and the ground is below them, they're falling. Well, they're just going to be, continuously falling. If you're in this position, you're just going to feel the air against you. You're not going to be able to, like, push yourself. You're not going to be able to move at all. You're going to be in completely free fall. So if you had, like, a scale at the bottom of your foot, and you and the scale are both falling, this scale is going to read out as 0, because the normal force here, uh, your normal force here, is going to be equal to 0. It's just that there's no ground here to push up against you to make you feel like you have some weight. And so a scale there, which measures your weight, would be showing 0. So when you're weightless, your normal force is 0. So I'm just going to draw the normal force here. It'll be Fn is equal to 0. And of course, this person will have gravity, mg. And since this is spinning, you'll have a centripetal acceleration into the circle. And I'm just going to say what's positive, what's negative. I'm going to say into the circle is positive, and out of the circle is going to be negative. So I'm going to go over here and draw my forces. There's only y forces here. So you have a normal force, which is going to be 0. You have force of gravity, which is equal to mg. And so if you remember, F net is equal to ma. And these are both vectors, and they point in the same direction. So your centripetal force is going to be equal to mg, because mg is in the direction of centripetal force. So mg supplies your centripetal force. So if you remember, Fc is equal to mv squared over r, and v is going to be equal to 2 pi r over t. You can plug this into this v, and you'll get mg is equal to m over r times 2 pi r over t quantity squared. And this is just, I just plug this, this v term into mv squared over r. And since this triple force is equal to mg, I said mg is equal to this thing here when the v is plugged in. So I'm going to draw this over here because I'll run out of room. So mg is equal to m times 4 pi squared r squared. That's an r, by the way. It'll be over r t squared. So this r, that r will cancel. Get r at the top, and that mass will cancel. So we'll get g is equal to 4 pi squared r over t squared. And t is period. It's a measure of revolution. It's a measure of seconds per revolution. So ultimately, we're going to be finding this because it's kind of close to the same units we have to find, just like a few conversions away. So I'm just going to multiply by t squared to both sides. We'll get t squared g is equal to 4 pi squared r. I'm going to divide g to both sides, and we'll get t is equal to t squared, sorry. T squared will be equal to 4 pi squared r over g. We can then square root this, and we'll get t is equal to the square root of 4 pi squared r over g. Now to find r, it tells us that we have a 270-foot diameter, which we're going to convert twice, so diameter is going to be 270 feet. This is 7 times, and then we have to use a conversion. I believe it's 0.3048 meters per 1 foot, and that will be equal to 82.296, and this will be in meters, and radius is equal to diameter over 2. So the radius is going to be equal to 41.148 meters. Okay, So now we can plug this radius into there, and gravity is, of course, just 9.8. So when we plug into there, I'm just going to turn myself a little room here, because room is all run out of room. So t will end up being equal to 12.875 seconds per revolution. I'm going to draw this in a way I can convert it easily. So seconds over revolutions. And we need to find the revolutions per minute. So first I'm going to get it into revolutions per second. And so that's a measure of frequency. And frequency is 1 over t, which will be equal to 1 over 12.875, which is going to be equal to 0.078 revolutions per second. So do another conversion here. It'll be 60 seconds per 1 minute. When you multiply that by 60, you'll get an answer of around 4.7 revolutions per minute. And so that is your final answer. Thank you for watching.